recorded, and if everything goes well, it will be posted to our YouTube page for the Tennessee Stormwater Association. Hold on, I have to take care of this real quick. So just remember to please use your Zoom etiquette. When not speaking, please have yourself on mute. Ben will let you know how he would like you to ask questions, whether via chat or just maybe just unmuting and asking a question. That is up to what he would like to do. And I will be sending out information tomorrow with your PDH certificate and any other information that Ben would like to send over to you. So I will be taking roll. If you were sent this link and did not sign up within the registration on my website, please either send me an email at charlene@tnstormwater.org or put your name and company and email in the chat so I can get you added to my list, because I see a few folks right now that are not on my list. And without further ado, I'm going to hand it over to Benjamin Willis. Thank you so much for joining us today and offering this to us, Benjamin.
Absolutely. Good afternoon, everybody. Just a couple of points for the questions. If you wouldn't mind just putting questions in the chat or in the comments, and we'll have time at the end as well for questions that we don't get to throughout the presentation. So as you're probably well aware, this presentation is going over water quality units, proprietary B&P devices. Let's see. There we go. And just want to go over a quick agenda for what we'll be covering today. First, we'll be going over certification protocols for water quality unit lists, different protocols that can be used to form a list, and the ones that we have reciprocity with, as well as we'll go into a new testing protocol for the TARP protocols through NJDEP, a couple of the changes that occurred in 2023, and it's caused a few changes in our list recently. From there, we'll go over general information regarding water quality units, what they are, what they do, how they can be used. And then from there, we'll look dig a little deeper and go into upstream attenuation and how that can be used to improve the size of water quality units. And from there, we will go into maintenance considerations for water quality units. And then again, from there, we'll have sizing requirements to be considered. And then we'll get into examples. We'll go over two examples, one being just on the paper, and then one that was real world that was submitted to us. And we'll go through the sizing requirements and what we can look out for in these examples. Going over testing protocols, there's two main ones in the US. There's the TARP protocols through New Jersey, and there's the TAPE protocols through Washington State. Here in Metro Nashville, we have reciprocity with NJDEP. They have their approval process, again, with the TARP protocols. And here's their manufacturer treatment device process. There's a few links here. Hopefully we can get that sent out to everybody. Good. It's just good information to see how they do their testing protocols. And then Washington State, they have their own protocols, mainly in-field testing. And back in the day, Metro Nashville did have a reciprocal relationship with Washington State's approval list, but for the past few years, we've switched to being solely reciprocal with the TARP protocols. Going on from there, the new testing protocols put in place by New Jersey was for their hydrodynamic separators, their 50% units. And this was introduced in 2023. A couple of these new requirements that were implemented in this test was, and this was true a little bit before for some of these, but the particle size, the average particle size had a diameter of 75 microns, the D50. There was the new testing protocols introduced a new slope requirement for the inlet and outlet pipes, as well as it changed the measuring protocols from grab samples into a mass balance requirement. And then also the dosing location was specified. And this might all be a little bit technical and hard to see, so have a little drop here. So here is how the testing protocol currently is with these new protocols. So you'd have your water tank over to the left. From there, you'd have a pump and a flow meter to measure the flow rates. From there, you'll have your dosing station. This will be the particles that you're adding into it, the at D50 of 75 micron, which again, may have skipped over this, but with a D50 of 75 micron, that's about 3 thousandths of an inch, human hair thickness, very small particles. And on the previous iteration, on the previous testing protocol, there wasn't a specification on where the dosing station could be. You could have it back far, 50, 40, 50 feet. There was no distance specified. In this new protocol, they've specified a distance of 3 foot. They've also added a minimum 1% slip on the inlet pipe requirement to ensure that the sediment gets to the water quality unit. Also, the change from grab samples to mass balance. Previously, in order to measure the removal efficiency of the water quality units, they would take a grab sample and they'd measure the remaining solids in that and see if it had less than 50% of the suspended solids still there. What they had noticed was on the inlet pipe, not all the sediment would sometimes get to the water quality unit. So since it never gets to the water quality unit, it never gets to your grab sample, which means that you think that it's been removed, although it hasn't. So a lot of these efforts were put in place to try and ensure that what it was actually removing was accurate. So instead of the grab samples, what they would do was do a mass balance. They would take out the material in the water quality unit and in the outfall. They dry it down and measure it by weight to ensure that at least 50% was removed. If so, it was then approved for 50% usage to the flow rates tested.
I have a question. Someone has a question.
Sure.
What does it mean when you say Nashville has reciprocity? Did I pronounce that right?
Yes, sorry. So yes, we have reciprocity with NJDEP's New Jersey Department of Environmental Protection, their approval list. They have an approved water quality unit list. And Metro Nashville, we have reciprocity, which means that anything that's good on their list is good on our list and is okay for use within Metro to the levels that it was approved for in New Jersey. Does that answer it? I think it.
So there is no formal agreement with NJDEP?
Uh,
Sorry, that's what she's asking.
uh, they do know that we have reciprocity with them. I've talked to them before, but this is where we get our list from. We see that it's been approved per their standards, and then it's okay for use in Metro Nashville as well.
Okay, sorry, this is Mary. I'll just ask. So there's no, when you say Nashville reciprocity, it means Nashville's policy is that you can use NJDEP approved devices?
Yes.
Okay, thank you. I
Yep.
appreciate it.
Yeah, no problem. But again, for the new testing protocol, essentially we're wanting to make sure that their test was accurately showing the removal rates of their devices, and that's why these changes happened. Now, getting on to some general information. Again, New Jersey has 36 devices that are currently approved, with 8 or 9 of them being the 50% units approved to this new standard. Now, again, there's two levels of approval rating that New Jersey approves to, the 50% and the 80% units. If it removes 50%, then it's approved for 50% removal. And that's true if it removes 50, 60, 70, 75, 78, 79. It's only approved for 50%, for an effective 50% usage in the system. It's not approved. They don't approve at 56 or 57% removal. So if you remove 79%, if you remove 51%, you're still a 50% unit in their testing. If in the testing, they run through it and you remove at least 80% of the total suspended solids, then you're approved for 80% usage in New Jersey and again in Metro Nashville. Now, going into the removal efficiency, as I had noted on a little earlier, the testing size of these of the particles that they're sending into their water quality units are very small. So, just for, I'm assuming everyone knows, but just in case anyone's not aware, for a micron, it's 1/1000th of a millimeter. So, for their particle sizing, so reading over this table, the particle size of 1,000 microns, which is 1 millimeter in diameter, all their sediment has to be less than a millimeter in diameter in their sediment going into their test. From there, at least 50% is less than 75 micron, which again is about 3/1000 of an inch. And then if you're getting up to 80% removal, you're getting down to 8 microns. You're getting into very fine particles.
I had more questions whenever you have a break.
Oh, sure.
Is there any formal test? Is there any formal testing done by Nashville, or is the sizing based solely on New Jersey testing? What micron size does Nashville test to?
Excellent question. Again, this is just through reciprocity 3 and JDP. We don't have our own testing that we do due to all the facilities that we required to actually implement this and run through it. It's trying to make the simplest and best approach for this. It's easy to just take their list and apply it to use in Metro Nashville. Again, we could try and mimic this and go through all the process ourselves, but it would take a lot of time, effort, and money. And it's much easier just to take another approved list, which is relatively comparable to Metro Nashville.
And the other question is, how was the decision made to go with New Jersey versus any other protocol? Was any soil evaluation done to ensure that 75 microns is appropriate?
This was actually a little bit before my time with Metro. I'm not sure the full discussion that went on with this. Again, this has been going on for years with having reciprocity through New Jersey. To figure out the best sizing, you could go and take soil samples all across Metro, again, go through the timing of it, and figure out what it is. We do have more clay here, which is probably smaller, so you could argue that it might be better to find to have a more stringent requirement. However, to go through all the time and effort to ensure that this meets these standards is very difficult. And again, it's good engineering. It's within reason. It is still relatively comparable. And again, the information is provided in a neat, orderly fashion, which allows ease of use in Metro.
And I'm sorry. Sorry, go ahead.
There wasn't that truck.
Sorry, somebody's talking.
Warehouse?
Yeah.
Sorry. I did want a follow-up question. As Nashville has significantly different soil than New Jersey, how is the New Jersey testing applicable to Nashville? I think you mentioned that, but I just wanted to ask. He had that question up there.
Yeah, again, just going a little in circles here. We could go through all that and try and make an applicable aggregate to mimic Metro Nashville, but we don't have that information at our fingertips already to go through an entire process through that, and then to go through that and try and mimic Nashville or Tennessee in general. If we had the information, we could try and use that instead. However, that information isn't readily available, and in the application of the units used here, it does seem to be doing the job of 50% and 80% units, and we're moving to relatively the same rates. What we could tell in the stream healths around Metro Nashville, given their usage before, and it seems to be working, and the information already being readily available through New Jersey and not through Tennessee, it makes it much easier, it makes a much simpler solution to have reciprocity through New Jersey. Yeah.
I'm on a Teams call with Metro Nashville. Yeah,
I'm sorry?
That's all I have right now. Sorry, I need to mute somebody.
probably 30, 45 minutes.
Okay.
What you
Sorry.
got? Yeah.
Going on into some more information regarding water quality units in general. There's two main two main types, apart from 50% and 80% in New Jersey. They have the GI and the non-GI. The GI just stands for green infrastructure. It's essentially a filter media with plants in it, and then the stormwater will go over it, filter through, and then get into the receiving stormwater infrastructure. Now in Metro Nashville, we have a couple different types of water quality treatments. We can have our LID methods, which are low impact development, or we have our volume 4, which includes proprietary devices, all water quality units. Again, this is more Nashville specific, but as the even though there are green infrastructure practices approved in the proprietary devices, these are still only used for the volume 4 non-LID sites. At least that's how we view it here in Metro Nashville, because a lot of the green infrastructure practices approved don't always infiltrate into the subsoils, because they have ways to actually connect to the storm system rather than traditional bioretention or pavers to infiltrate into the ground. And again, another difference between different units that can be approved. There are filters and there's hydrodynamic separators. Again, this is A's versus 50s. And the real two main difference between these things are cost and effectiveness. 80% in general cost more money. However, they remove more of the stuff that's in the water. So you get a better removal rate, but it does generally cost a little bit more.
And I had a question is, what does GI stand for?
Yeah, GI just stands for green infrastructure, and non-GI would be non-green infrastructure.
Okay.
It's two differences quantified by New Jersey in NJDEP. Again, a non-GI device will either just have filters or hydrodynamic separators or baffles, whereas green infrastructure will have plant life in it, in the media, to help with the evapotranspiration and the removal rates. Getting on into online versus offline units. When each of these devices is tested, they are then preloaded with a certain amount of sediment into their capture areas, and then more water is run through the device. After it's run, they will take samples from the effluent to ensure that you don't resuspend the particles that have already been captured. So for instance, if a device receives, let's say, 2 CFS and it removes 50% of the solids, great. But then it receives 5 CFS and it resuspends everything it captured, well, then you can't have it be receiving flows of 5 CFS or more. Now, for them, they generally test to at least 200% of the MTFR of what it was rated for treatment. However, it can go up a little bit higher, varies, but by each of the individual water quality units. So if it's rated for online usage, then it can receive flows in excess of its MTFR, which, again, if I haven't said this, the MTFR is the maximum treatment flow rate. It is the maximum rate at which flows can be received that it can effectively treat for either 50% or 80% based on what it was rated for. But again, even if it's rated for online usage, if it receives, well, it was tested to show that it receives, let's say, 250% of the MTFR. If it could treat 2 CFS effectively, and then in the testing, it says it won't resuspend the solids at 5 CFS. It doesn't mean that if you send 15 CFS, it won't resuspend the solids. So you want to make sure that if it's receiving flows greater than its scouring limit, that there is some sort of bypass to ensure that it doesn't exceed what it was tested for. Again, it was only tested for 200% or 250%. And you can read it in the reports, in the testing reports. And as long as those flows aren't exceeded, then it shouldn't scour. If they are exceeded, then you have the possibility of scouring, and you'll need to have some sort of outside bypass to ensure it doesn't receive these flows. Getting into sizing limitations. So for all water quality units, regardless if it's a 50% unit or an 80% unit, if it's green infrastructure or non-green infrastructure, if it's a filter or hydrodynamic separator, they all have the same limiting factors: the flow rate coming into the device and the drainage area which it's treating. And smaller water, now again, as I mentioned a little bit earlier, smaller water quality units can often be used if the flows are attenuated. However, you still have to ensure that the water quality unit is sized appropriately for the drainage area. Even if you've reduced the flow rates going into it, you can't eliminate all the filters. If you have, we'll get on into this in the examples, but if you have, a 1 acre site and it's draining all to a vault with a bunch of filters in it, if you choke all the flow down to where only one filter can handle it, it will quickly blind over and it will quickly become used up, and will have to be cleaned out and replaced before a general maintenance cycle. So let's see. Yeah, going on into it, for the water quality units, for the drainage area there at the bottom, it's based on a 600 pound per acre per year maintenance cycle with maintenance of 50% volume. To explain a little better, if you have a site and it's 1 acre of completely impervious area and it drains to your water quality unit, if it can hold 1,200 pounds of sediment, then that would mean at 600 pounds, it would be 50% full, which would mean that after 1 year, we're assuming 600 pounds of sediment come off of impervious areas per acre per year, that after 12 months, you'd have to clean out the device and ensure everything's in working order, and then you wait for the next year to re-inspect it. Here in Metro Nashville, we have maintenance cycles of 1 year. So as long as the drainage areas don't exceed, and again, that's how they're sized through NJDEP, with assuming a maintenance cycle of 1 year. So there will be an associated maximum flow rate and maximum drainage area with the devices. And this is based, again, on maintenance of 50% volume and drainage in each of the impervious 600 pounds per acre per year for impervious area. So that's for the drainage area. For flow rates, there's a couple methods you can use to calculate the flow rates going to the devices. One of the simplest is the rational method, Q equals CIA. Q being the flow rate to the device, C being the runoff coefficient, I the rainfall intensity, and A your overall drainage area. Now, that being said, you can also adjust it by using upstream attenuation, checking the flows down, having less flow go to the device, so that way you can use a smaller device. Now, I'll go on into it a little bit deeper later on. For rainfall intensities in Metro Nashville, we have 2.45 inches per hour for our water quality design storm. That'll vary depending on where you're at. It is completely area dependent. And then for runoff coefficients, again, it varies based on individual site locations. Here I have a little table going over general runoff coefficients. You can look and see it varies based on slopes as well as what the ground cover is. So if you have impervious area, it's generally 95%. If you got woodlands and it's relatively flat, you're looking at runoff coefficient around 0.1. So the lower your runoff coefficient is, the slower water moves. The higher your runoff coefficient is, the faster it moves, which makes sense because Q equals CIA, smaller number, smaller flow rate, higher number, higher flow rate. Going on from there, going into general water quality review applications. if you're reviewing water quality units, a couple things need to be evaluated apart from just the flow rates and the drainage area to them. I got a call from someone in a different county asking me a question about if a water quality unit could be placed in a specific location. It was about 150 feet away from the parking lot. It was down like a 2-to-1 slope in a pond berm, way away from where everything else was going on. And first thing I noticed was, well, that's a bit far away. Where's your travel path going to be? Also, for this specific device, I was like, okay, let's look at the maintenance documents. For all these water quality units, each manufacturer will have an associated maintenance and maintenance documents going over what you need to clean out these devices, how to inspect them, what the indicators are for failure, and those are all available on Metro's device list as well as through NJDEP. But I looked over the maintenance documents for this specific device, and I was like, huh, it says that it needs a vac truck in order to clean out the filters here. Like, okay, well, that's going to be pretty difficult to get a vac truck, all the way out there. Now you can add in some extensions in the tubes and on the hoses and get it out there. But if you put a water quality unit a far ways away from any access point, you make it difficult to get to, it generally doesn't get maintained. The point of these things is to remove the suspended solids in the water. But if you can't maintain them, they only work for the first year or so. Here in Metro, we have a lot of water quality units in our system already. If they're far away, if they're behind the building and hard to get to, it's just hard for anyone to actually, most of the time they don't get maintained. I'd say most of the time. It's less likely for them to get maintained than one that's out in the open, easy for them to access. For the vac truck drivers or any of the ones who are going out there and maintaining it, first thing I'll tell you is they want to be able to get to it, the travel path to get there. And when they get there, they want to have enough space to actually work and ensure they can inspect it and clean it out appropriately. Also, for just accessibility and safety, you don't want to put these in places that it's dangerous to get to or places that just don't make sense. Now, from this, we'll get into a couple sizing examples. Just a quick disclaimer, this is how Metro sizes our units. This is only applicable within our service boundary. And the units chosen in these examples were completely at random. Every product on our list has the same endorsement. We could have done this with any of the devices that we have approved for use in Metro. These were just chosen at random and just for sake of time. So going on there, first sizing example, we're going to assume that we have a site. It's going to be an acre site. It's 100% impervious. We're going to assume that we're going to use a perk filter here. And we're going to assume that this all drains to one drainage basin. So a parking lot. We have a lot of these in Nashville. Great. See them all the time. Fantastic. If they drain in one spot, even easier. Now, if this drained to 2 basins or 3 basins or 4 basins, well, then you need 2, 3, 4 units to ensure that you actually treat all the flows. Again, I say treat all the flows. Take it with a quick grain of salt. You're supposed to treat all this area. However, all practicable area. You're supposed to treat all the practical area you can. However, the driveway entrance, it's unlikely that you can actually be able to redirect that flow into the site to where it can get to the perk filter and get to your your dry pond, your water quality pond, or any practice for that matter. In reality, you might only get 0.95 or 0.98. You're going to get most of it, but just use good engineering judgment and ensure that you can get as much as possible. Now, in this example, we're not playing in the real world. We're playing an example, so we can assume that we're going to treat the entire acre site. Going on into this, first thing we need to do is calculate the flow rate going to the device. Now, we're not going to be using upstream attenuation. I assumed a little bit of a higher C at 0.99 for the runoff coefficient rather than a traditional 0.95. Again, the I is the rainfall intensity for Metro Nashville. It's 2.45 inches an hour. And then the acre is pretty simple. It's still an acre. And that equals 2.43 CFS. Now, again, if anyone's just a quick math check, an acre inch per hour, that doesn't exactly look like a cubic foot per second. Well, if you run through the math as I have shown here, it's about the same. An acre inch per hour converts about 1.008 to 1. So we're going to just treat it as 1 for our practice. It's a good general practice to just treat it as 1. You can add in the rate if you want to, but again, for our purposes, it's fine. Going on to this, now that we have our flow rates going to the device, we need to make sure that we have enough filters to treat that flow rate. This model CF96PF MHYZ, it's a volt. So they have a volt and it can hold 14 18-inch filters. Again, it can hold 14 18-inch filters. The volt itself doesn't actually treat the water. So if you get a specific volt and you say, oh, this can treat this many units or this much flow rate, it's great. But for any device using filters, you got to make sure that they're actually putting in all the filters that are required. If they put in, 6 filters rather than 14, it wouldn't get wouldn't have the same removal rating as all 14. Again, though, with a volt that has 14 18-inch filters, we're only at 0.636 CFS, so you need to bump it up to have 4 overall volts with 56 filters. And then you'd have MTFR, the manufactured treatment maximum treatment flow rate of 2.54 CFS. Now, since that number is in excess of the flow rate going to it for the water quality flow rate, it's good. It meets the flow rate requirement. Again, though, we need to ensure that this effectively treats the drainage area as well. And so if I go back real quick, you can see for 18-inch filters, the maximum allowable drainage area is 0.07 acres. Well, 56 filters times that 0.07, you're getting 3.94 acres, well in excess of 1 acre of impervious area. Since this can effectively treat the flow rate and the drainage area, it looks like this should be good for use. A couple quick note that I don't have listed out here. This specific volt, it has an bypass, an overflow bypass already built in. So we don't have to look at the scouring rates because it's already been taken care of. If flows are in excess of the MTFR, it should bypass. We could inspect the bypass to ensure that it's properly sized. But in general principle, if there's already a bypass, then it will be good to go. From there, we're going to go on and look at the same example, but instead of just using the rational method to estimate the flows going to the device, we're going to attenuate the flows. So if we're going to attenuate the flows, the first thing we need to do is figure out what our water quality volume is. So beforehand, we've been looking at flow rates. Now we're going to be looking at volumes. The water quality flow rate was based on the rainfall intensity for the water quality design storm, which is 2.45 inches per hour. The volume in the water quality rain event is 1.1 inches. Water quality volume is equal to the rainfall for the 1.1 inch 85% storm event times the runoff coefficient times site area divided by 12. Runoff coefficient 0.015 plus 0.0092 times the site impervious cover. Works it all out, it's 3,733 cubic feet. Great. Now that we have a water quality volume, we can try and figure out what our flow rate is going to be from this. But in order to do that, we have to choke down the flows first. So we're going to make a couple assumptions real quick here. Well, we're going to assume that we have an underground detention that's going to go to this perk filter. We're going to assume it's going to be a 40 by 50 underground detention, so 2,000 square feet. Gravity is 32.2 feet per second. Hopefully that stays constant. we're going to assume that we have an orifice of 2.5 inch in diameter. And then our discharge coefficient, we're going to assume 0.66. This is generally applicable for this sort of orifice. Again, 0.6 to 0.8, somewhere in that range. 0.66 is a fairly good estimation. Just plugging into the orifice equation, you're getting a flow rate of about 0.25 CFS. So now that we have our attenuated flow with,
Ben?
I'm sorry, yes?
Hey, will you explain what attenuate the flow means to everyone?
I'm
We have a
sorry,
lot of people who are very new to all this.
I'm sorry, I might be going a
It's
little
okay.
fast.
You're doing wonderful. Thank you.
Yeah. So, sorry, I didn't cover this earlier. For attenuate the flow, when I say attenuate, what I mean is you're going to have an upstream detention. You're going to have either an underground detention or a detention pond. You're going to have some way to collect the flows before it gets to the unit, and you'll have some sort of orifice, to slowly allow the water to leave the tanks that have contained it. Since you have a giant pond or an underground detention or whatever it is, since it's collecting the flows and then slowly trickling the flow, since it's collecting all the water and then slowly trickling the flow to the water quality unit, you don't have as great a flow to the water quality unit, which means that it can treat it better. Because remember, these devices were tested to treat to have 80% or 50% removal at certain flow rates. So if you choke the flow down, well, then it's going to meet it every time because you can always choke it down to, a quarter CFS. So it's a lot easier to treat. In our earlier example, we were like, 2.5 CFS. It's a little harder to treat 2.5 cubic feet of water coming at you than a quarter CFS coming at you. So that's what we're doing here is we have an underground detention upstream of the water quality unit that all the entire acre drains to. And inside that, there's going to be an outlet control structure, and we're going to assume that there's a 2.5 inch diameter orifice at the bottom that allows the flow to leave before getting to the water quality unit. Again, in Metro Nashville, we have requirements on what the flow rates can be between the 2 and 100-year storm events. So there will also probably be other weirs and rear walls in conjunction with this orifice and in conjunction with the outlet control structure. But for this example, all we're looking at is the flow rates to the water quality unit to ensure that it is properly sized. So from there, knowing that we have we shut the flows down to a quarter of a CFS going to the perk filter. We now can use this model Volt. It's a CF48PFVYZ. It's got 9 12-inch cartridges, and they have a maximum treatment flow rate of 0.272 CFS, which is higher than the flow rates coming to it, which means that it will remove 80% of the flows that are coming to it for the water quality volume. The problem, though, is that 9 12-inch cartridges have a maximum drainage area of 0.421 acres. Again, this maximum drainage area is based on a sediment load of 600 pounds per acre per year of impervious area. So that means that if it's 0.421 acres is what 9 12-inch cartridges can handle, that would mean if you have an acre going to it, in what would that be? 40% of a year. So about 5 months in, 6 months in, these filters would no longer be usable. They'd be full. Well, they'd be 50%, but for our purposes, they would need to be maintained at that point. Now, in Nashville, we have a maintenance cycle of 12 months. So every 12 months, they need to go out and be maintained. And if this is, starting to blind over every 5 or 6 months, then it no longer meets that requirement. As such, they would need to increase the number of cartridges. They need to switch volts to a volt that could actually hold the required number of cartridges. And if you can get up to 30 12-inch cartridges, you can get a maximum drainage area of 1.41 acres. And again, it will have a maximum treatment flow rate of 0.9 CFS. Now, a couple things to note here if you're a designer, if you're looking at this, you're well in excess of both the requirements. You well exceed the water quality flow rate going to it, and you exceed the drainage area requirement. So you could cut down the number of cartridges here, get closer to 1 acre for the maximum drainage area, but your MTFR is still going to be somewhere 0.7 or so, 0.6 CFS, which means you've choked that flow down far more than you actually needed to. That upstream underground detention that's choking this water down, it takes up a certain amount of area which could be used for other development. So really, you could decrease the amount of area that you're contributing for your underground detention and allow, flow rates of, half CFS to go to the unit, because the limiting factor here is going to be the drainage area rather than the flow rates. And this is a cyclical process. You can go through it or an iterative process, and you can go through it and try and make these two come into balance where your drainage area and your MTFR are both met adequately without one being disproportionately exceeded. From here, we'll go into our second example. For our second example, we will have a 3.21 acre site. It's going to be 54.5% impervious. We're going to use a HydroShield Advanced Plus, and we're going to have, again, just one basin rather than multiple basins. I use this example because this is one that was submitted to us. So in reviewing, here's what we're looking at. Here's what we want to be seeing when they submit to us. For this site, in their calc package, they had a little paragraph here going over what their plan was for this device. The old Castle infrastructure, HydroShield Advance, it goes over, it says removes 50% of the total suspended solids at the treatment flow rate. The system was sized based on water quality flow rate of the 2.45 inches per hour from the contributing basin. And then it says, furthermore, the system has a bypass capacity that exceeds the 10-year peak flow from the contributing basin. The water quality flow rate is as follows. As I had said for the scouring earlier, so they were only tested for a certain amount. The reason they mentioned the 10-year is we don't want the scouring rates to exceed, we don't want the water quality units to receive flows in excess of the scouring rate up to the 10-year event, because that's what our public storms infrastructure is built to. Once you start getting 25, 50, 100-year storm events, we're more looking at, people's safety rather than the water quality. So that's why when we get these incredibly large storm events, we're able to allow higher flow rates through the devices because everything's having higher flow rates. But again, for this specific example, they had this nice little equation. It's fantastic. They have 3.21 acres. Their runoff coefficient, they calculated previously on this page, was 0.63. And then for Metro Nashville, our rainfall intensity is 2.45 inches an hour. We're getting 4.93 cubic feet per second. Again, this calc package, they have a different area where they have a map, and they say their area to the detention pond, which the area to the detention pond and the water quality unit was the same. If it's not the same, they need to show the information differently, but in this example, it was. And it shows 3.21 acres, 1.75 of impervious, a little bit more than 50%, which made sense. And time concentration of 5 minutes. And over here, that's their detail for the device. It was a 6-foot unit. Going from here, we're going to use our rational method to calculate the water quality flow rate. And we're getting 0.63, 2.45, 3.21, 4.93 CFS. It's what they had said in their calculation package right here, 4.93 CFS. We get the same thing. Also, just a quick point, you are all probably familiar with it. The rational method does have its limitations. When I say that time of concentration of 5 minutes, it's good to check that. Rational method's good for about 5 to 25 minutes of a time concentration, and for drainage basins that are less than 100 acres. In Metro Nashville, that's about 99% of sites. We generally don't have drainage basins with water quality units receiving the flows that are in excess of 100 acres. But good to know that we're still within the realms of reasonability for the rational method. But again, cubical CIA, we're getting 4.93 CFS is the water quality flow rate. And the detail they had provided on the previous page was for the 6-foot unit, and it doesn't quite have the MTFR to treat it. So in reality, for this specific site, they'll need to upsize it to an 8-foot unit, something with a MTFR of 5.96. This is in excess of the water quality flow rate, so it should meet the requirements. And just a quick, tip or trick whenever you're looking at these. If they don't have upstream attenuation, the limiting factor is always going to be the MTFR. It's going to be sized appropriately to receive to treat the area required if it can also receive the flow rates. As such, if they were to upsize to the 8-foot device, this would meet the flow rate as well as the drainage area. However, another thing to be looking at for this device, it doesn't come with an installed bypass weir. Looking at their 10-year storm event, we're looking at scouring. Looking at the 10-year event, we were getting peak flows of almost 16 CFS, and in their report, they were only tested for 220% of the MTFR. As such, they're going to be a little bit low in terms of their scouring rates, so we will want them to install some sort of bypass to ensure those flows in excess of 220 of the scouring rate do not enter the water quality unit and resuspend those solids that have been collected.
I have a question about example 2. How did they determine how to use the 2-year, 3-month storm event and get an intensity of 2.5 inches an hour?
So again, it's not the 2-year, 3-month storm event. It's not accurate. It's just the 3-month. But the 2.45 inches an hour, the rainfall intensity, that is Metro's rainfall. That is the rainfall intensity for Metro's water quality storm event. Our water quality storm event is the first 1.1 inches or 2.45 inches per hour. And that's just standard in Metro. Again, depending on where you are, if you receive higher flows, that may be different. But that's what it is in Metro.
Thank you.
Yep, no problem. But going from there, just a quick summary. So for proprietary BMP device lists, the two main approval agencies are the TARP protocol and the TAPE protocol. TARP through NJDEP, TAPE through Washington State. For online and offline devices, you have to consider the scouring limit. You can't have flow rates that exceed these scouring limits to resuspend the solids that were collected. For upstream attenuation, remember you can shut these flows down, but the drainage area still has to be met in order to let the maintenance cycles be under that 12-month operating window. And then for all maintenance considerations, just remember to make sure these things are accessible in the future so people can get back out there and let these things keep on doing what they're doing. Here I have a quick helpful links list. This has Metro Nashville's approval list, as well as our Stormwater Management Manual Volume 1, and then NJDEP and Washington State links as well. And that's all I have for today. So if you have any questions, be happy to take them.
I would say go ahead and unmute if you have any questions that have not been answered yet. That would be fine.
Hey, Ben, did you were saying that they need to provide additional bypassing for scour. Do you just make them put in an additional pipe that goes around the unit and into the outlet structure pipe?
Oftentimes, yeah.
What do you guys normally see?
There's a couple different ways to do it. I have seen sometimes where they just upsize the unit because then your MTFR is higher, and so your scouring rate's also higher. And as long as that's not exceeded through the 10-year event, they're good to go. Generally, though, the main method is they'll have a diversion structure prior to the device to where flow rates in excess of the scouring rate bypass through another pipe, like you said, and just go to this exact same outfall point.
Ben, does Metro accept the Washington State units for both hydrodynamic separators and filter units?
I'm sorry, you cut out a little bit there. What I think you said was if we accepted Washington State's approval lists for both their units.
Yes.
Yeah, unfortunately, no. All we have reciprocity with is the TARP protocols through New Jersey. Back in the day, we did have approval with Washington as well, but since then, this was years ago, we've switched to solely being through New Jersey.
Okay, well, follow-up question, I'm sorry. Chapter 7.5.1 of the Metro Stormwater Manual lists specific requirements for submittal for approval for units outside of NJDEP. What is the review process and the expectation to receive an approval and or denial from the city?
Yeah, so there in our volume one, in our stormwater management manual, in volume one, there is a process to where you can apply for approval apart from our reciprocity within JDEP. It's more cumbersome process. Oh shoot, did I skip that? It's it's generally the easiest practice is to have approval through NJDEP and then reciprocity through us. You can apply. You can apply for approval through us. Then it has to go through our processes, meet through all our groups, and at that point, it's all laid out there on on what the requirements are.
Oh, I understand that. My question is, what is the time frame to receive a response from Metro when you make a submittal under the following subsections of Chapter 7.5?
Again, our main job here is more for development. Mine specific is more for development review projects. There's no specific timeline for these, as that's not our main function. So yeah, there's no defined timeline to it. It's reviewed when we get to it.
Does Metro have or foresee in the future having to update their MS4 permit anytime soon? And if so, how are you expecting that to change your program?
I'm not too sure. So updating their MS4 permit
with TDEC?
You guys will be updating your phase one soon. Most of that doesn't go through Ben. I think this whole discussion today was just to let people understand how there are what we all need to be getting as a phase two. Obviously, Metro is a phase one. Our guidelines are a little different for us phase twos. Like, what do you need to get when people submit these devices? How do we review these devices? That was the whole idea of Ben helping us as smaller MS4s come along beside and learn how to do these a little bit better. So Ben, you did a wonderful job of helping us with that. I also want to say that like most, well, maybe not all, but some of the phase twos also have obviously their own SEM manuals, and they can decide whether or not they want to use Washington tape or approve that as such. Ben is just letting us know what they do. So I didn't want there to be any confusion about why we were hosting this, and it's not to put Ben on the spot. It's really to help us understand how to do these better.
Thank you.
I have a question about attenuating the flow and putting your treatment device downstream of a pond or a detention system.
Mm-hmm.
Does that not allow any of the trash that you're attempting to treat in your unit to be in your detention system or your pond or whatever, thus defeating the purpose of the unit in the first place? If you slow the water down, isn't it reasonable to assume that your sediments will fall out in your detention system?
That's an excellent question. To some degree, yes, they will. You're increasing the time it takes for them to move, which means that some will fall out. That being said, in Metro Nashville, we have a couple different types of detention. One of them is a dry detention pond that has its own removal rating of 60% for total suspended solids. For that, we would require it to be we would require the pond to be downstream of a 50% unit because it's a higher removal rating. For underground detentions, we don't ascribe them any we don't ascribe them any treatment capabilities. They will remove some, yes, but there's no, great documentation of going through testing and seeing what they will have, especially because for underground detentions, in this example, we had a 40 by 50 vault. However, I mean, you can make them in any shape and size, so you'd have an infinite amount of configurations you could have these to where it would make it a lot more difficult to nail down exactly what the removal rates are. Again, and for that instance, if you were draining from something, an underground detention to an 80% unit, since we're only trying to treat to the 80% TSS removal, you should be effectively removing that. Either way, you might get a little bit upstream, yes, but in the end, it should be still a net benefit.
Thank you so much, Ben, for doing this today. I really, really appreciate it. It's a lot of really good information. And I will be sending out some backup information, some follow-up information with your PDA certificates. If you had signed on and you did not sign up on my registration form, I may not have your email. So if you could email me at charlene@tnstormwater.org, if this was sent to you in an email and was not sent from me. And also, Ben, I had a request if you are comfortable with sending me these slides, I can send that out at a PDH. That is, PDF. That's up to you.
Yeah, sure.
Okay, great. I've had someone ask me about that. And if there's any other follow-up information that you would like me to send out, I will wait till tomorrow to send this out. So I would just say by lunchtime tomorrow, if there's anything that you would like sent, Ben, just please let me know.
All right. Thank you. I appreciate it.
Thank you so much for doing this today. We love to have our tens of talks and we really appreciate you. And we've never met in person, so hopefully I can meet you at some point.
Hopefully. Are you going to be in the Tennessee Engineers Conference in Franklin?
Yes, come by the Tenza booth. Yes.
Good deal. I guess I'll see you there then.
I will be there Monday and Tuesday.
Good deal.
Awesome. Thank you all for attending. If you have any further questions, you can contact Ben or anyone at Metro. And thanks, you guys, and have a good rest of your day.
All right.
Thank you.
Thank you.
Thanks, Ben.
I need to stop recording.